Hello everyone. In this video, we will begin to examine topic 1, measurement and uncertainties, and in particular, we will start to unpack 1.1, measurements in physics. More particularly, we will begin to examine fundamental and derived SI units and scientific notation and metric multipliers. So, before we begin with sort of learning about the physical world, it's actually really important that we have certain prerequisite conversations about how we know about the physical world. In other words, how we know about physics and physical things at all. And that means we have to spend sort of a semi-boring unit discussing measurements in physics, what it is to measure something in physics, and how we go about it. So the first thing I want to define and want to sort of speak about is what is known as a physical quantity. Okay, a physical quantity is defined as the measurable properties of the physical world. So we're going to unpack this. First, to note, this triple line here, if you haven't seen before, means is defined as, okay? So this is what it is to be a physical quantity. And what comes over here on the right side in the definition is sometimes, for definitional purposes, only a rephrasing of what's on the left. So that can be a little bit challenging. But this is simply designed to explain what it is this is, okay? And it is important to recognize that physics is fundamentally about how the world works. But physics isn't the only discipline in which you learn about how the world works. For example, in sociology, you study the social relationships between people and society and institutions and structures. And strictly speaking, and in fact, in reality, those are about the world, the real world. But we won't be concerned with them in physics. What will we be concerned with? We will primarily be concerned with what are called these physical quantities, these measurable properties of the physical world. Now, there are going to be some times when we run across concepts where it's not clear if you can directly measure them or not. And we will cross that bridge when we come to it. But for now, let us define a physical quantity as a measurable property. Notice we're also already defining this as a quantity, okay? So something that can be quantitatively cashed out or analyzed. Physical quantities are measured in units. You're going to have a certain amount of them, okay? So we'll discuss a bunch of them in a bit, but for example, length or distance is a physical quantity. And you can assign a number to particular lengths. It makes sense to talk about something as being twice as long as something else. So that's how you know it's a quantity. It's related to number. And it's measured in units. Okay, so there are lots of different types of units. But if you measure a length in one unit and you know the conversion to another unit, you can directly convert. That is, the unit doesn't change the length of a thing. Something might be 100 centimeters, or it might be 1 meter, but fundamentally the length of that thing is the same. Okay, the units don't affect the actual quantity. But we do need to talk about units, and in fact there are two different types of units for you to know about. Okay, there are what are called fundamental or base units, which are the 7 quantities from which all the others are defined, and then derived units. These are units that depend on the fundamental units. Okay, so all of these derived units take their definition from what we can think of as the OG7 here. Now, you could have a system that picked a different 7 from the ones that we use. The ones that we use are called SI units for Système International. Apologies to the French speakers, because that is supposed to be in French. But they're related to the international system of units. Sometimes in the States, people will refer to this as the metric system. And those will be the units that we use almost exclusively in this class. There are some exceptions, but we will get to those when we get to them. All right. And these fundamental or base units are a particular 7 that you need to know. We will use several of them throughout the course, and at least one of them I might mention literally one time later in the course. Okay, so we use them at different rates depending on their importance. Those fundamental 7 are length. Okay, with the unit meter, spelled either in the British fashion, RE, or the American fashion, ER. And every physical quantity is given a symbol. So there's a symbol for the physical quantity. And that physical quantity is measured using its units, also given a symbol. Okay, it is very important to begin distinguishing between the quantity itself, for example, length or distance, in the unit with which we measure it. Most people tend not to do this with length, but here's what it would sound like in length to mistake the unit for the quantity. You might ask somebody how long something is by asking, how many meters is it? Now, that's not the worst mistake in the world. It's pretty clear what you mean. But I want to encourage you to begin thinking about whether you're asking for a physical quantity or whether you're asking for the unit, okay? A sort of worse version of this might be asking somebody, what's the meterage of this particular thing, which most people would not do. But you do hear in some later contexts quite often. For example, you'll often hear voltage used in that particular way. So, other physical quantities that we think are important besides length or distance or height, which are all ways of talking about extension, would be mass, measured with the kilogram, time, measured with the second, electrical current, measured with the ampere, temperature, measured with Kelvin, or degrees Celsius, and we'll discuss the relationship between them a little bit later. So Kelvin or degrees Celsius. Amount, and this is a tricky one. So the SI unit of amount is a mole, and we'll discuss that more later on. And luminous intensity. This is the one we may see one time later. I'm not even going to explain sort of ultimately what it is. You can look it up if you like, but it's on this list just for completeness. And those fundamental quantities are then combined in different ways to produce derived physical quantities. So, if we're thinking about velocity or speed is measured in meters per second, written like this: m divided by s, or equivalently, m times s to the negative 1. Notice those mean the same thing. Notice that this unit, meters per second, or m divided by s, is a combination of two of the fundamental units. So meters and seconds are used to produce this new unit, meters per second. The vast majority of physical quantities are exactly like that. Even if they have their own named unit, which we'll see in a second, even if they have a unit that's just for them, it can be cashed out, or it depends on fundamental units. So density, given the Greek letter rho here, the Greek symbol rho, has units of kilograms per meter cubed, or a kilogram m to the negative 3. Force has the unit Newton. Okay, and that's an example of a named unit for a force. But a Newton, as we will see, is a kilogram times meters per second squared. a kilogram times meters per second squared, written like this. So a newton, even though we use newtons because using that unit makes it easier to convey forces. It's just a lot easier to say that than this mess. Nevertheless means a kilogram meter per second squared, or a kilogram meter times seconds to the -2. Okay, so we have fundamental units and quantities and derived units and quantities, and it's important to recognize that on another system, okay, and this will be more obvious later, we could have picked a different set of fundamental ones. But given our system, the SI system, the one that we're going to use, these 7 are our fundamental quantities. Now, to convey units, sometimes we think of it as a unit conversion when what we're doing is really just using a metric multiplier. And I will talk that way too. So sometimes we'll talk about converting centimeters to meters. Now, what the centi in centimeter is doing is simply standing in for a certain number of powers of 10. In this particular case, centi is 1/100th, and so that is 10 to the -2 meters. So centi there means 10 to the -2. That's all it means. So there's a sneaky sense in which centimeter is not really a different unit from meters, although of course we'll all talk that way. It's really just saying a particular amount of meters, and it's more efficient to say it that way. Centimeter is a lot easier to say and a lot easier to convey than 10 to the -2 meters, or 1/100th of a meter. We will be using all kinds of metric multipliers, and in fact, you will eventually memorize a whole bunch of them if you have not memorized them already. Now, I wouldn't encourage you to memorize the table of metric multipliers given here, because they are, in fact, in your data booklet, which if you have not seen already, you should take a look at. So the IB data booklet. Given this table, you can always look the metric multipliers up, and we will use many of them. Many of them are more or less common, so I'm just going to highlight the ones we're going to see all the time. We will see centi. We will see milli for 1/1000th, 10 to the -3. And as we move into smaller and smaller things, right, we're going to tackle atomic, nuclear, and particle physics, we will certainly see micro, given the symbol mu here. That's the Greek letter mu, written like this. Notice that's different from milli, which is the Greek, standard alphabetic symbol for M. And then nano, 10 to the -9, which is an N. Sometimes you see smaller things than that, but if you're unsure, we will look them up. At the high end, we won't very often see hecto or deca, but we do see kilo quite a bit. Kilo with a K, mega, 10 to the 6th, giga, 10 to the 9th, and usually after that, you don't see them as common. So we'll use sort of that subset quite a bit. One thing it's important to note, mega is often in ordinary colloquial English given the phrase million. And giga in American English is given the word billion. I would encourage you, though, to get out of the habit of using billion in particular. And the reason for that is because in some parts of the world, in English, the word billion doesn't mean 10 to the 9th. It means 10 to the 12th. So in certain uses of the word billion, that just means 10 to the 6th, 10 to the 6th, a million millions, rather than 1,000 millions, which is what giga is. So I would encourage you not to use the word billion because it can be ambiguous, and instead to get used to using these metric multipliers as necessary.